Now let's look at this second point over here, which is a kilometer away from the negative body, and so almost a kilometer away from the positive body too. We do the same thing. The electromotive intensity produced by body A is equal to the charge producing the field over r squared. The charge remains the same, it's plus 20, and r squared is 1001 meters squared. And you can see if the test charge is 1,000 meters away from body B, it's 1,001 meters away from body A. So this is plus 20 divided by, let's just leave it like that, 1001 squared. And then the electric intensity from body B is equal to the charge over r squared, and that is equal to minus 5 over 1,000 squared, a million, I guess. So that's minus 5 over 1,000 squared. Now you can tell that the numbers in the denominator, 1,000 squared is almost the same as 1,001 squared. They will both make the force very, very tiny, but they will be essentially the same as each other. They'll vary very little. Whereas now the 20 is still 4 times larger than the 5, and so the resultant intensity, which will be 20 over 1001 squared minus 5 over 1000 squared, will be very tiny but positive, almost 4 times as much positive as it is negative, because the denominator in this case affects both forces, both intensities, almost equally. And so what you'll have is that over here you'll have this kind of intensity, and over here you'll have a very tiny intensity pushing out. So if you get far enough from both charges, the field just becomes outward pointing and very small. And I'm going to pause and show you one more thing.